preparing live stream. I'll let you know when we're on here.
I just got an indicator at the upper left says we are.
It's still.
Yes, I see the live.
Okay, go ahead.
Mine says live also.
Live stream.
Okay, Ron, do the intro.
All right, everybody, listen, welcome aboard. We're doing it again. It's our third installment. That's right, season 1, episode 3 of the weekly Santa Barbara Astronomical Unit podcast. It's weekly, not twice a month like it used to be in radio days. Members of the South Coast Longtime Telescope and Astronomy Club, the SBAU, are going to present every Monday morning, 11 a.m., right here on Zoom, and quite often right on YouTube. You can watch. Stand by, folks, for a full hour of cutting-edge space developments, new scientific discoveries, some astrophysics, and SBAU club news. My name is Baron Ron Herron. I proudly hosted a similar program on radio for many years with these gentlemen. And proudly, the program can be seen on YouTube, thanks to Tom. And now let's meet the gang from SB's Astronomical Unit. Ladies and gentlemen, our two-time, going on three-time probably, president, beloved Jerry Wilson. Good morning, sir.
Good morning.
I assume, like the rest of us, you've had your second shot, or no, I haven't had my second shot. Have you had yours?
Second cup of coffee this morning.
Second cup of coffee. Meet the outreach coordinator who somehow during this pandemic is doing some outreach coordinating. It's virtual, but
Here and there.
Chuck McPartland, good morning. You're going to have to tell us if anything else is due in the future. And our webmaster, overworked, distinguished technician, former President Tom Totten, the upper left corner. And joining us at home, beloved Westmont science instructor and the editor of our incredible newsletter, which you can get. I'm not sure if you can get it if you're not a member, but we want you to be a member. Hello, Tom Whittemore.
Hi. You can always get it, I guess, at SBAU.org.
Oh, it's always posted. In fact, all of the old.
I'll usually post them. Yeah.
How long have you been editing our paper, our little?
Oh my God. I think Chuck would know better, but I think it was the beginning of 2004.
That sounds
Okay.
about right.
President Jerry, do you have another article on there this month?
Not yet. I have to write one. I get to write one.
Thanks.
Oh,
Thanks again.
Yeah.
well, you did one for the March edition, I assume.
Yeah.
Up to date, yes.
We're in mid-March. Well, we got a lot to talk about, gentlemen. I'm just going to run down some of the things. Zodiacal light, something I never knew existed, is up there. We'll give you. Yes, who's talking, gentlemen?
Oh,
we have. Huh?
I said yes. I was really glad to see Jerry posting that beautiful photo from the Skull Valley.
Well, here it's coming on screen right now, I think, thanks
Okay.
to Tom. And I barely see it. Is it just sort of because, oh, there it is. How come I see it better on yours than in my inbox?
Yeah, it's gorgeous. I mean, Skull Valley is just shy of the Great Salt Lake. And so when you're looking to the west, okay, where you'll see the zodiacal light after sundown, it's really dark. It's really dark there. Okay. To the east, of course, you have Salt Lake City, and it's quite bright. So that's a gorgeous shot that Jerry posted.
But now, if that's on the ecliptic, which is turned at an angle to our position on the Earth, as I guess you know, I hope I'm right. Why do we not see the Milky Way? Where is it in relation to this?
The Milky Way doesn't correspond to the ecliptic. The ecliptic
Right.
is where the planets move.
Oh,
Plane of the Earth's orbit. So right now the Milky Way is.
It'd be off to the left in that image.
Yeah.
That's right.
oh,
You see the zodiacal light in that picture along the horizon. It's brighter on the right side, and that brightness extends up in sort of a parabola or top half of an ellipse, and that follows the line of the ecliptic.
Right. It's this time of the year that you can see this wonderful thing. If you get to a dark place, because the ecliptic is canted almost vertical to the horizon right now, and that's the same. I just mentioned this is the same time of the year that you get the little smiley crescent moons. The really pretty crescent moons. They happen very close to the equinox, which is coming up shortly.
and the tip of that is up in the constellation Aries, Taurus, Pleiades area.
Yeah.
In this picture, yes.
And can this be seen every night of the year or just certain
No, you
times?
have to have.
Oh, no.
Yeah, go ahead.
Oh,
Wait,
no,
Go ahead.
you
Tom.
go ahead, Jerry. You post that beautiful photo.
Oh, well, The light is shining off of, this is dust that's in the ecliptic plane that is beyond the Earth. It's on the opposite side of the Earth as the sun. So the sun is shining around the Earth and it's illuminating this dust. And then we see the dust, light reflected off the dust. Quite irritating to astrophotographer like myself. But it's a pretty sight, and it can only be seen under very dark sky conditions. It's not a real bright light.
But
So,
is that dust in an, is it in an orbit of its own?
Yes.
well, it's in an orbit. We're going to get to that, but it's been speculated for a long time that this is due to just dust thrown off into the solar system by passing comets and asteroids and things like that. But there's a new paper out that discusses it probably is dust from Mars and in an orbit defined by Mars orbit.
Okay, so it's in there next to the asteroids? That's
It's,
past Mars, isn't it?
yeah, that's past Mars.
Yeah,
Okay,
interestingly, the photo captures Mars up near the Pleiades.
Yeah,
You can see a little dot up there near the
Oh.
Pleiades.
yeah.
the brightest star up there next to the Pleiades.
But I remember, Jerry, reading something in your description about Jupiter's involved somehow.
Yeah, Jupiter is the dominant gravitational force besides the sun in our solar system. And it keeps the dust, same way it keeps the asteroids from forming into a planetoid, it keeps the dust on the Earth side of Mars.
Okay, now Jupiter, my understanding, there are some, what do they call them? Shepherd asteroids within the orbit of Jupiter, ahead of it and behind it, but that's not what this is, right?
Those are the Trojan asteroids, and
Trojan.
that's not what this is.
Ah, so this is just primordial dust from the beginning that never
No,
coalesced, and formed into
No.
rocks.
no, it seems to come from Mars.
Yeah,
It comes from Mars.
the data they start from is that they detailed the distribution of this dust. And they did it fortuitously because the dust is hard to detect. And it's, you get these pictures from Earth like this, and several probes have been sent out to measure the dust, but their collection area was way too small and the dust is too thin. So they never got any real usable data. But the Juno probe, when it was on its way to Jupiter, they realized that they were getting impact. They were feeling impacts on the spacecraft, and so the spacecraft itself had a much bigger collection area. So they got a good distribution of the dust as they traveled through this region between the Earth and Mars and beyond Mars. And their data that they got from the probe is highlighted there in the middle of the abstract of the paper I quoted. It says the observed distribution is consistent with a primary source of dust particles sharing the plane between Earth and the 4-to-1 resonance. Wait a minute, I gotta slide that over to read that. Sharing the Mars orbit plane between Earth and the 4-to-1 resonance with Jupiter. So Jupiter is a strong source out there, just like it is on the asteroids.
Would it be safe to say that this dust could have become a planet at one time and just didn't?
No, for the same reason, it's not gonna. It's being distributed around by the gravitational forces. There's not, and the dust is too light and too small. It doesn't have any turbulent irregularities in it that causes big clumps to form.
So it wouldn't be dangerous if a bunch of astronauts going hundreds of thousands of miles an hour through it, the dust wouldn't go through the spaceship?
Juno survived flying through it,
Oh, it did.
so astronauts would too.
But it was detecting the impacts because little bits were knocked off of the solar panels by the dust, and they were seeing the bits of the solar panel go flying past. And
Yeah, in
so,
the camera.
yeah, so it does a little bit of damage.
Listen, somebody might want to add to this because I saw another ugly gentleman's face on the screen. Our sixth joiner is, I think, Bruce Murdoch. Are you there?
Yes, I am. Okay. Oh, hello there.
Bruce, if you
Can
had
you
your
hear me?
shot, if you haven't had your shot, you can't join us. I'm sorry.
Can you
Are
hear me?
okay?
Yeah,
Can
we
you
can
hear
hear
me?
you, Bruce. We hear
Okay.
you.
Bruce Murdoch, ladies and gentlemen, a stalwart longtime member, very active gentleman. Also, I guess the president still of the Santa Barbara Theater Organ Society. Bruce?
That's correct.
All right. Well, welcome aboard. Glad to have you aboard. You're welcome to join in. We got lots to talk about. Have you, just out of curiosity, heard of this zodiacal light? Have you ever photographed it or looked at it?
Both.
Both.
Heard of
huh?
it, and I photographed it.
So it's always on the other side of the sun, but it's obviously the left or right side. We couldn't
Ron,
see.
Ron,
What?
it's distributed all over, but you only see it when it's on the opposite side of the sun because the light is reflecting from it.
Okay. And in relation to the asteroid belt, where is this dust? Is it just scattered everywhere from here on out?
It's not in the asteroid belt. It's inside Mars orbit.
Oh, it is.
Tom, can you show the graphic that's in the email that shows the Earth and the?
There it is.
Yeah.
Is that it? Okay. It looks like a slice of pie about the size I would have.
Yeah.
Secondary.
Yeah, so it's cut away a bit, but it surrounds, it goes all the way around in the orbit. It fills it all, but it's cut away to show the inside of it here. And that's the dust distribution that they measured as they went through. Now, of course, they didn't cover all this territory. They went through it, and then they assumed that it was spherically or axially symmetric, and so they filled it in. But it does seem to be where they measured it. They went through, I believe, once. How many times did it orbit the sun before it went to Jupiter? It was several times, wasn't it? Or do you recall?
I don't think with Juno. I think that was a direct mission.
Just a straight through shot, huh? Okay. So
They all
anyway,
use-
that shows the distribution of it. You can see Mars in the middle of it, over on the right-hand side, in the middle of the sandwich. So it does go a little bit out the side of it. It's in the one, it's between 1 astronomical unit and 2 astronomical units in this diagram, which is the 4-to-1 resonance point out on the ecliptic with Jupiter. It's got a secondary and a primary distribution, and that distribution is cross-sectioned in the next plot, the graph. Can you show that graph, Tom?
The next one. Oh, okay. Here.
Yeah. Outer peaks at 9.5 degrees and stuff. So that's the cross-sectional distribution sliced through the ecliptic. And you see it shows a red line, which is the modeled thing, and it shows the IRAS, the black line, which is the data. And when they fit the data to their model that it comes from Mars, then it fits very well. And that's the basis of their conclusion that Mars is the real source of this dust.
Although they still haven't been able to explain how the dust escapes Mars's gravity and distributes itself around. So,
well, when you're a scientist, you've always got to leave a question open so you can follow on paper.
Well, Mars certainly has enough dust on its own, as we all know.
It does.
Do you happen to know, Mr. President, what Gaussian part removed is?
Yes, it's just an earlier fit to the general distribution. Before they had any data, it was just a guess. A Gaussian fit is just a simple mathematical model.
It's a bell curve.
It's a bell curve, yeah.
Yeah, interesting stuff. I don't want to say that dust doesn't get the respect in the universe or in the galaxy like planets and stars, but there's a lot of dust out there. There's huge dust clouds that our stars are forming in. Is it the same kind of, what?
We are a big clump of dust, but it formed under different conditions. This is not going to form into a planetoid.
Well, the thing that's hard for me to understand is how a bunch of dust in space can coalesce and become a hard rock.
The key there is gravity.
Well, I know, but there's not a lot of gravity in an asteroid that's only a few feet across, and yet it's a hard, big piece of rock. How in the world did it get that hard?
Well, it wasn't always that way, maybe. Some of the asteroids were part of a fully differentiated planet or planetoid, because like the iron ones, there had to be a planet that was semi-liquid or at least plastic for the iron to go down to the center and form a core. And then later there was a collision and the crust got knocked off and we just have the real rugged core left. So we know those asteroids came from a bigger body and they were in a collision. The smaller ones, there are many of them that are just rock, just gravel piles What was the one they just landed on that they took a sample of?
Ryugu.
Ryugu? Yeah.
Oh.
Thanks. So
Well, is there
there's all
anything?
sorts of crap out there.
Is there anything in common between your asteroid belt and, let's say, this dust and Saturn's rings? Are they basically all the same stuff?
Saturn's rings are primarily ice.
Oh, as are comets, are they not?
Yes.
And comets come from way outside the big shell called the Oort cloud, mostly, right? They get bumped inward. And
Right, from the Oort cloud.
still, it's kind of interesting how that all works. And our moon's got a lot of dust, as you saw the astronauts clumping around on it, but that's from collisions with asteroids, impacts, meteors
Yeah.
Yes.
It's just,
that ground everything up.
yeah.
What we want to do, I want to give a quick shot here. If your school or organization would like a virtual outreach class discussion via Zoom, is that how you're doing it these days, Mr. Outreach Coordinator Chuck?
Well, I haven't been doing very many classroom Zooms. I did one of those, but we've been doing some Zoom telescope star party type things.
Right. And you had one successful one last month, didn't you?
Yes.
How long did that last?
Ooh, about hour and a half, 2 hours.
And it was just you sitting on a Zoom screen like now with
No, it was Javier with a telescope, me with a telescope, Charlotte Ziemer at the museum, Owen Duncan at the museum. So we had a bunch of people in on it, plus the teacher and all the students.
That's right. Bruce Murdoch, were you aware Javier has stepped down? He's not our connection.
Oh, yeah,
anymore.
yes, that was in the newsletter, I believe.
What have you been watching lately on your scope?
Fog.
Just while we're briefly on outreach,
Yeah.
I just got an announcement today that Santa Maria has and Allen Hancock College, the leadership of Santa Maria Valley Group and Allen Hancock College have developed a mobile observatory, and they're premiering it the Saturday coming up on the 20th. I believe that's Saturday. Yeah. And if you, it's not very big here, but I try to do a share screen.
Wow.
Can you see their little mobile observatory there?
Yeah, there it is.
Yeah.
So it's,
Pulled by a truck and they can set that up and it doesn't have to be planted anywhere, just
right.
park.
And they're planning to bring it around to schools and various public events.
Maybe someday it'll be at our Saturday night star party at the museum.
There's really no easy way to pull that thing into where our star party is.
Oh, is that? Plus we got an observatory.
Right. So anyway,
Yeah.
just a bit of news there.
So Chuck, who owns that? Who owns that
Up
mobile
there. I guess it's
observatory?
functional.
I guess the Recreation Parks District of Santa Maria and Allen Hancock College are together in running it.
Wow. I wonder what it costs. Where do you get something like that? Where do you buy something like that?
Well, they bought a trailer and then they modified it to put a dome, a plastic or a fiberglass probably dome on top of it, and the scope inside. They probably had to put jacks on it to jack it up and level it and make it stable.
Yeah.
Although if you're just doing outreach, you're not quite as worried about being super stable as you are if you're doing astrophotography.
Well,
Right,
listen.
but it probably wiggles a lot when you walk around inside.
You walk around in it, yeah.
I wonder if the back and forth online about President Jerry's incredible 12.5 inch astrograph scope, that's really spurned a lot of reaction from members. What is it about? Is that the scope you're using now, President Jerry?
When I use the scope, yeah, yes.
You debuted it at CalStar. And what is CalStar again?
Oh, that's the California Star Party. It used to be the end of the year Star Party, and it was usually around the 1st of October or the last end of September, depending. It followed the full moon, or excuse me, the new moon around. And now they've last couple of years they've started one in the springtime too, which is coming up in April. They carry them out in Lake San Antonio.
Lake San Antonio. Is that in our state?
Yeah, it's in Paso Robles, and then it's west from Paso Robles for
And
about an hour up into the mountains. It's a very dark site. When the weather's good, which it almost always is in the fall, usually hotter than hell during the daytime, but
Really?
very nice at night. And the seeing is steady, very, very good, and very dark skies. We were out there one time at 2 a.m. It's a camp out, and it's over 4 nights. But we were out there one night about 2 a.m. in shorts, sandals, and t-shirts.
Yeah.
Weather was so mild.
Have all of you been there? Tom
Oh, yeah.
Whittemore?
Yeah,
Yeah.
I mean, the original CalStar was started by my old club, the San Jose Club, and we used to meet up at Lassen Volcanic Park, and basically we were allowed to camp there for free because we would show the public campers the night sky. There was a group of astrophotographers that would go up to, I forget what it's called. It's where all those mud pots are. But we used to be down what was called the devastated area.
Bumpus Hill?
I can't remember what it was called, but the astrophotographers didn't really participate in the showing the public things. And so we kind of separated ourselves from them. And we were down at the devastated area, which is still about 6,000 feet up. Very, very, very dark. That particular star party, CalStar, was the start, basically, of the parties that now meet at Lake San Antonio.
Yeah.
And the original ones that we used to do, I was still up in the Bay Area. The original ones was about the year, I believe, 2000 or 2001. And we used to meet at, like I said, Lassen Volcanic Park. Really nice, very, very dark.
Tom, there's a meetup there nowadays called Shingletown Star Party.
Yeah, that's right. It turned into that.
Okay.
Yeah.
And then to point out also, the CalStar is not open to the public.
That's right.
You
Yeah.
have to bring your own scope, and it's for observing and photography and doing your own thing. But we all walk around and look through each other's scopes. Everybody.
Sure. Yeah.
So
Nice shared activity.
Sounds like a heck of a camp out. Is there any indoor meetings and speakers
No.
to come and talk?
No.
It's a star party.
Yeah.
Really? So you've all gone to it? Tom Totten, have you been there?
No, I have not.
Yeah, I've been to several. Tim Crawford would often join us too, the early ones. These again are the ones that would be at Lake San Antonio. Okay.
And it's
Okay,
less
got
dark than it used to be. There's a lot more housing development around it. And stuff.
Okay. I haven't been there in a while, Chuck.
But
Neither
you
have
didn't
I,
go.
but-
You didn't go last September though. That would have
I've
been.
been there for years, Baron. So,
Oh, I see. Okay. Well,
Yeah.
I wonder if it was even staged in the pandemic. That would be right in the middle of it all. Well,
a good
gentlemen,
contact for that would be Joe Doyle. He would often go to all of them. I know Jerry went.
It did happen last year, but I didn't go.
Yeah.
Yeah. And they're having one next month.
Yeah.
They have a
They are?
spring one now
That's
too.
the
So
new
there's one in
springtime
April.
in April.
wow.
Depends on the
CalStar.
weather.
Okay. Well, Joe Doyle is the one that sends us all the crazy jokes online, isn't he?
Mhm. Now,
Wait,
if you don't go to this CalStar Star Party, then no matter what went on there, you will hear how wonderful it was. If you
All right.
go, you may sit outside all night with an umbrella.
Well, my impression, Mr. President Jerry, is that you debut your new instruments and you actually brought that 12.5 incher. That
No, I brought all sorts of things. One year I brought 2 telescopes because my son went along and I set up a 6-inch f9 refractor for him to look through. And then I had the 12-inch that I was imaging through.
well, you seem to be upgrading. Probably all of you are from time to time. I know a couple of years ago you gave me your computer, which I have yet to hook up, but it looks like a great computer. I'm on this little laptop. So
Oh.
is this Astrograph the one the new one now in the Wilson household that's being used?
Well, I'm about 90% complete with an 18-inch f4 astrograph.
18-inch. My God, there I go. Do they get any bigger than that for us private users?
Not for me.
Oh, for you? 18. That's
Charles Schuler
I'm getting
Charles
too old.
Schuler now has a Explorer Scientific 20-inch.
Yeah.
20-inch.
I think it's about f3.5 or something like that. You know, he and I
Now that's-
around the new moon go out and try to find locations where we can see the night sky. We have to go away from the light pollution of Galeta, but either East Camino Cielo or we go up Highway 101, and there's a number of places where you can get off the highway and not see the lights of the cars.
Yeah, the largest scope I ever built was an 18-inch, Ron.
Really?
Yeah, f4.5.
Now we're talking about the diameter of the mirror in the back.
Mirror,
right?
yeah, that was made from scratch. Ground and polished and figured the mirror, built the whole telescope. I finished it in 2000, and that was at CalStar. I believe in 2003 or 4 when I hooked up with Tim Crawford and a couple of people who were working on telescopes in the workshop I started, including Jeremy Schmidt. I know a lot of folks here will remember Jeremy. He was really smart and built a beautiful 10-inch telescope at the same time that Tim was building his. Tim Crawford.
Right.
And the biggest amateur scope I've heard of that somebody has is a 60-inch. 60. Yeah.
That's major. That's probably as big as the one that Hubble looked through on Mount Wilson back then.
No, he was looking through the 100-inch. I haven't heard of a 60-inch amateur scope. The biggest scope I heard was the Yard scope, which was 36 inches.
Well, they also had a 48-inch CDK there one year at RTMC.
Oh, okay.
I was going to mention that when I was still up north, there was a group of folks building a 70-incher. Okay. And actually learned a lot from them about, how to make, really good mirrors. It was a community project, just a whole bunch of people building the 70-incher, and they were recently looking for a place to plop it. I don't know where they ended up doing it. I think they wanted it in like Northern California, though, if I remember right.
Oh. Well,
one of the times that I was at Mount Pinos, there was 2 guys that had this big reflector. I'm not sure how big it is. It certainly was 36 inch. The thing was huge. It was tall. They had to be on a big step ladder to get up and go through it.
Yeah.
Well, as the weak link in the club, and the club is devoted primarily to telescopes and astrophysics and whatnot, I got one quick question that may lead into another discussion, or we can use it as another day. It dawned on me recently, gentlemen, that visual or optical telescopes, which is what we use, have to have a tube for some reason. And I realized that radio telescopes, which are dealing with the same photons on the electromagnetic spectrum, only at a different frequency, do not. I give the Webb as an example, or any of the big dishes on the Earth. Why is that? Why is there a tube required?
You don't need a tube on our telescopes either. The tube is just to keep stray light out. If you go to a super dark site, you will see scopes without tubes.
Ah.
Well, there's a minimalist mount. Oh, I'm sorry.
Go ahead, Bruce.
There's a minimalist mount. I think that Jurgen has it, which is nothing more than the mirror and a pole and the secondary and a holder for the eyepiece. I mean, it's completely open.
Yeah.
There was a guy who used to collect all kinds of stuff. And he came to our once to one of our meetings, and he had a telescope that was simply a 2x4 with a mirror nailed at one end, on a little triangle of wood, and then a hole drilled in the 2x4 up at the far end where you could put an eyepiece, and stuck out on a nail was a secondary mirror. And so that was his minimalist telescope.
That telescope was actually suggested in one of the original amateur telescope making books from Scientific American.
But that over flooding you're talking about doesn't happen with radioscopy, if you will.
You get radio interference too, but they put their radio telescopes far away, and they very selectively pick a frequency band to look in. That is putting essentially a filter over the telescope to keep all that other stuff out.
Well, can the private parties like ourselves buy a radio telescope on a small scale, or do they even work that small?
There's one at the museum, an amateur size one, and I have one in my closet. It's just made from a wok, basically, for the antenna. And it's got a TV, people have the TV antennas to pick up satellite TV. It's got one of those as the receiver, and you've got a little, it talks to just a voltmeter, and all you see is a little arrow that moves as it picks up a signal. But you can see TV satellites, you can detect the moon, you can detect the sun, and you can detect people emit radio waves too. And so you can, kids at some of the outreaches, when we have clouds, we bring that, and they point them at each other, and you can see the needle jump because they're warm, and so they're giving off some microwaves.
Yeah.
And that walk just happened to be configured at the exact right
You
curve.
may not realize this, but walks are optically parabolic.
Yeah.
It's
And that's
okay,
what
they're
it's-
not really. They're not really.
It was close enough, you know.
Yeah.
And
What-
Chuck,
what-
you
Let's take a hammer and figure
remember
them.
Jerry?
Right. That's
I
how
tried-
you correct one.
That was a
I've got-
member of our club who now lives in Missouri, Jerry Polivka. He worked on some of the big radio telescopes that are down in Mexico now. And he's off in Missouri now, but he made amateur kits that you could buy to make your own radio telescope.
Yeah.
Huh. Well, I noted that all the ones we have in space, your Hubble, are optical and they've got big tubes on them, but they're
Not
about to
all of
launch.
them.
Huh?
Not all of them. I mean,
The
they're
radio
X-ray
ones-
telescopes too.
What is?
X-ray, the Newton XMM and
I'm
Chandra.
talking about optical.
Okay.
Optical, as you guys said, you guys buy a telescope, you want a tube with it. You don't just have the mirror nailed on the end of a two before.
Well, the tube is partially to hold parts of in the right position too. So
I see. Interesting. What's the name of that giant, just went out of commission in Puerto Rico, the Arecibo? Is that,
yeah,
Yeah. Yeah.
it's no longer, we don't have anything that big
no,
anymore.
it's permanently out of commission.
Yeah. Fell
The
down.
Chinese have one that's even bigger.
Yeah.
What's even bigger?
The
The
Chinese
Chinese.
built one.
Those large arrays in the desert do more just by having several smaller ones in a row, don't they?
It's a trade-off.
Yeah.
Bruce, you're moving around. Is everything okay?
Yeah, I'm just trying to find a better position for my my tablet computer here.
Well, you guys are all better lit than I am. I got to tell you, I'm just sitting here. Here we go, changing things around. Can we
Oh.
change the subject to a couple of things that we got in Jerry's talking points? I'm not sure if you want to go.
Well,
Yes.
Tom's got a picture of Tim Crawford and Jürgen looking at a Dobsonian, I think it is.
Yeah. That Jürgen built that.
Yeah.
That's a telescope?
Yeah. And see,
Mhm.
there's no tube on it.
Oh, you're kidding me.
No.
So, and it doesn't look curved at the bottom or top. It's all squares. It's a
It's a
box.
13-inch mirror.
Where? At the bottom?
Down
At the
under
bottom.
He's got
Under
it.
that white square of paper or whatever that is?
That's
I
the
think he's
mirror
just
cover.
protecting it.
Yeah, that's not the mirror.
Now that's
Mirror's under that.
that's homemade, or can you buy that from?
No,
Dobsonian.
he made that. That's homemade.
That's
You-
homemade.
You make Jürgen a good enough offer, he'll probably sell it.
And you'll see, I'm actually there looking at it too. That was,
Oh,
it was
yeah.
he showed that at one of the Astro days down at the museum. You can see the creek in the background.
Wow.
Really impressive thing he put together, Jürgen. He's really good.
Yeah.
I'm sorry. Who's the gentleman with the beard in the picture?
Yes, Jürgen Hilmer,
Oh, Jürgen.
club
Okay.
member.
Should have seen him at some of the meetings.
Well,
You
you
know-
don't see him that much because he does most of his astronomy between 3 a.m. and sunrise.
Okay, one of those.
He lives up on the mountain.
Love to ask him about zodiacal light. Are any
Sure
of
you've
you?
seen it.
Apparently, every week we get the week's postings from either Astronomy magazine or Sky and Telescope from Jerry. And I guess you can't see these nights anything after dark.
Oh, no, this is a wonderful time of the year, especially during the dark of the moon right now. If the sky is clear, because when you look in your night sky, you're looking at one of the poles, the North Pole of the galaxy. So the Milky Way is not in your way. So if, like I do, you like to look at other galaxies, this is the time to look at them. You can see the Virgo cluster. You can see bright galaxies in Leo, the Leo triplet, which are magnitude about 8 or 9 or something. They're easy photo objects. They're fairly big compared to most galaxies. So this is a wonderful time of year. The problem with this is in California, it's usually overcast, marine layer or raining or something. So
Yeah, I was going to say the sky was kind of wet last night.
Yeah, it is here too.
That's right. It rained. Well,
Yeah.
then does it do any good to talk about checking out asteroid 4 Vesta this evening, for
Sure.
example?
You're an asteroid buff?
Well, I'm looking at one. He's our outreach coordinator. Not sure if Vesta would occultate. Is that the word? Occult or
Occult. Occult.
occult? Occult is the word. Have you been
It
doing?
has. There have been a couple of occultations with Vesta.
Okay.
None that I've observed.
And then Tuesday night, Carl, moon will pass Uranus to the south in the sky. South means down, I guess, right?
Oh, Ron,
And then-
also tonight, tomorrow night, Tuesday night and Wednesday night, there are two really good International Space Station passes coming over Santa Barbara. So on Tuesday night at 8:41 is the start. From the southwest to the west-northwest, it'll be quite bright. And then Wednesday night, 7:54 is the start. It's going to go pretty much, across the sky from the south-southwest to the east-northeast. They're going to start in about Eridanus and, end up over by Canis Venatici. Although the first one, the one Tuesday night, is actually going to go into the Earth's shadow when it reaches Gemini. So,
Really?
Yeah.
How long does that transit take? It's over in no time, isn't it?
It's
pretty quick.
a couple of minutes. The long one on Wednesday night is about 6 minutes long. You can see
Can you-
minus 3.8 on Tuesday, where Tom is displaying it there. So
Yeah.
on 16 March, it's minus 3.8. Tom, click on the date. Click on 16 March, and it'll show the star map. So it shows how it starts off in Eridanus, it goes up along Orion, and it goes into the Earth's shadow when it gets between Gemini and Auriga. So that's pretty cool to watch it fade away as it enters the Earth's shadow.
Wow. But, they have a posting on YouTube of Constant looking down at the Earth from the space station.
Yeah.
It would be kind of neat to look at it going over in the sky and have on your screen looking down on ourselves, wouldn't it, if we pair that up? But you'd probably not see nothing but clouds.
Well, you could shine a green laser up.
Okay.
We
How
can-
often when you're looking at it, what?
We can see the ISS from quite a long slant range when they wouldn't be overhead for us.
What is this
So-
on the
so
screen
They wouldn't
now?
be
What,
seeing us.
is that looking down at the Earth or is that up in the sky, Tom?
This
Oh,
is a
that's
sky
sky.
view here. This is Wednesday night's pass. You can see it goes right by Sirius down below
Oh.
there.
I got you.
And then it goes up through the sickle of Leo, and then it disappears over in Canis Venatici below the Big Dipper.
Well, the space station orbits the Earth about the same length of time as the old Apollo and Mercury astronauts, an hour and a half. Was that a good figure? Is that about
10
right?
minutes.
It's good.
So in between these two passes, it's probably orbited the Earth another dozen times at least, I would imagine.
Yeah.
Mhm.
This is just one that's illuminated that you can see naked eye.
Incidentally, on not Jeopardy, Who Wants to Be a Millionaire last night, one of the questions was the name of the NASA program to put a woman on the moon within the next year and a half. You know what the ancient goddess of hunting was? You know what?
Artemis.
Diana?
Artemis.
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 Artemis. Yeah.
It might be Artemis. You never
Yeah,
know.
that's the Artemis project.
There it is.
And
Women on the moon.
This is
Everybody's
what-
heading for.
this is the 12% crescent moon, as the caption says. This is what it will look like tomorrow night.
Okay.
So
And
you
that's
can see
how-
Mark Crisium, the dark spot on the right over there. Now there is a contest, sort of a informal contest to try and photograph the moon at the smallest crescent that you can get. This crescent is way too big to qualify for that contest, but people have taken lunar pictures of the crescent that's only one day or 1.5 days old, and it's just the barest sliver.
Yeah.
Well, now,
Gary, why can we see the moon that's not lit up by the sun? Where is that light coming from?
That's reflected off the Earth's oceans.
Right.
Earthshine.
Earth's-
oh,
Yeah.
well, you get two different crescents. One at the beginning of a phase of the new moon, and then the
One
old
when
moon is disappearing, and it goes to the other
one's when
side.
it's waxing and one's when it's waning. This type of moon, when you see it in the visual naked eye with the crescent and the old moon, it's called the old moon and the new moon's arms.
Yeah.
And what you're basically seeing is both sides of the full moon when it's full, that you would normally see everything. You're only seeing the edges, right? With the
In
crescent.
the sunlit part, you're seeing it emphasizes shadows.
Yeah, but it's still the only side we see. And
That's right.
and
Whether
in
it's
China,
light-
We see about 60%, Ron, because it wiggles back and forth because it's in an elliptical orbit.
oh, is that right? 60 boy. Okay, but China's park
it wiggles like
what?
this.
does it really?
Yeah, I
Right.
did that once for you on a radio show and got ridiculed for skewing a graphic on the radio show.
Yeah.
Nobody saw it.
That's not, it's not physically doing that. It's just from our point of view, it looks like it's doing that because it's in an elliptical orbit.
Right.
Well, apogee by Thursday. That's as far out as it gets, right?
And
How
then
far is that?
on Saturday, on the 20th, which is also happens to be the equinox, between 5 and 6 p.m., if you look along the terminator, the dark bright line there where it's becoming morning on the moon, you can see the lunar X, which is where it's dawn on the tips of a bunch of mountainous rims that are around some intersecting craters, and it looks like the letter X. So it'll be along the terminator, but kind of on the southern edge of the moon, the down edge of the moon.
Oh,
And it doesn't last very long.
Yeah, so about an hour between 5 and 6.
Tom,
really?
if you can find there's a nice little short clip video of the moon's nutation. If you can look that up, it's very, very startling.
There is an X there.
There's a video, though, a motion picture of a time lapse of it over a month or two.
So this is the time of the month when you guys like the moon.
There it is. You had it up there in the upper right.
Go back, Tom, I guess.
We just want a picture of the nutation, not there. That I think that's it.
That's it, Tom.
Yeah.
Uh-huh. Okay. We get all the Maoris on our side, but I understand China is parked on the opposite side, aren't they, right now?
They have a rover there, yes.
Okay, this does not look like the video I was envisioning.
Oh,
There it is.
well, we got rovers all over Mars, and we got non-roving
See how the moon is twisting as the phases advance? Well,
yeah.
that's not the graphic that I was looking for.
Right.
So
Not bad.
Yeah, it's close to it.
So now we learn late in our life that nothing is a perfect orbit. There's not even a circular orbit for the Earth around the sun, is there? We have an apogee in it.
There is, but we're not in it.
What do you mean we're not in it? Where else are we? We're on the Earth.
We're on the Earth, but we're in an elliptical orbit.
Venus has a nearly perfect circular orbit.
Yeah.
Well, there are some elliptical orbits that would fry you one part of the year and then freeze you the rest, wouldn't they? If they were really crazy.
Well, if you're an asteroid, they really go, I mean, a comet, they really go out there. They go out past, you go back out in the Oort cloud and come back in.
Hey, Chuck, what's the difference between libration and nutation?
Libration is what we see, and its nutation is a much faster motion of the moon wobbling around its axis. So we don't really see that. But this libration is this apparent motion that we see from the Earth.
Right. Yeah. Nutation comes from the word to nod. And the way I used to teach about it was the moon basically bobs up and down from our perspective by about 5 degrees. So we can see on top of the moon sometimes and on the bottom of the moon sometimes. Then the other thing is the moon goes faster sometimes in its orbit and slower sometimes. So we look around the left side or we look around the right side. So like Chuck said, we see much more than 50%. We see in the range of 60-ish% of the moon because of those two, because of those two motions. Okay.
If you look at the picture you've got up there now, on the right side, when it starts lightening up again, you'll see Marcrisium there. And now watch, Marcrisium will move toward the limb.
Yes, good point, Jerry.
And it almost disappears around the limb, which means that if we look at the other side of the moon, you can see more of what was on the backside.
Are you saying Marcrisium?
Marcrisium, Sea of Crises.
Oh.
Crisium.
Right. There's a beautiful crater right on the rim called Proclus, and it has this dust chain you can see at this time of the moon's age, you know, the face of the moon. Really, really pretty. Jurgen pointed that out to me one time, and I never forgot it. And so I would show people that at star parties.
So Tom, you had Tom Totten, you had a nice graphic up about 3 or 4 times ago that showed the graphic definition of nutation and rotation.
Huh.
I don't know if you could find that again, but.
Is the moon's ecliptic roughly about where above our equator? You understand that question?
the orbit of the moon is tilted 5
Yeah,
degrees
that's it.
relative to ours.
Tilted.
So it's not exactly on the above the equator.
No, and it's not exactly along the ecliptic either.
Right, right.
Ecliptic. Wow.
Nothing lines up perfectly.
Yeah, and the a libration is not a libation either.
Not a what?
Libation. Libation
Oh,
is
libation.
Nothing to
drink.
Something you drink with freshly baked sourdough bread right out of the Whittemore oven.
Yeah.
Yeah.
Fascinating stuff, but I'm just barely hanging on here, gentlemen. You're going to have to keep me alive and keep going on it. I can't wait till we start booking.
What you need is the knowledge that there's a test and all this coming up in a few days. And that'll focus your attention on these things.
Yeah.
Yeah, you're absolutely right. Well, now there was, we should probably talk about Curiosity, which is in the news again, NASA, and Perseverance, Percy. We're getting some awesome photos from the surface of Mars,
Oh, yeah.
even the undercarriage of the 6-wheel rover. I don't know if they've launched the helicopter Ingenuity yet. Has that flown? It hasn't.
No, they're looking for a flat area to set it down.
Oh, it looks pretty flat. Everything I see, just amazing how they pick the right spots. I look in the distance and I see those boulders and rocks and think,
Perseverance had a terrain matching system, a radar and optical terrain matching system. So it picked where it was going to set down, and it picked a relatively flat spot. But they want a really, really flat spot for the helicopter because this is, it's a test and it's fragile, and they want to make sure they get it right.
and all those mountains, there it is. Thank you, Tom, for bringing all that up. Those mountains in the distance are the edge of that Jezero crater, where a giant asteroid or something hit.
Yeah, and I think this might be the delta they're showing here that they want to go to.
Delta, meaning
the
water.
delta where the debris, the sedimentary stuff from the incoming river into the crater.
Okay. When are they going to start digging, you think?
Don't know.
So they got 2 years on this, don't they? Isn't that what it's estimated?
Well, they're going to go way past that, but that's the nominal mission length right now.
Yeah.
And it's powered by solar.
No.
Oh, it's not solar.
It's got a nuclear reactor on the tail. That's the butt that sticks up in the air a little bit. It's a thermal isotope, whatever they call it.
Radioisotope thermal generator.
Yeah.
RTG.
Really? First of the rovers to have that.
No, Curiosity had it.
Curiosity's got, so that's why it's still going.
Yeah.
And the one that dusted over and lost its power.
Yep.
Thanks
an
to
opportunity. Yeah.
That would came back to life when a dust devil hit it, I guess, on Mars.
Well, one of them is parked on a hill that doesn't allow it to collect enough sunlight when the sun hits it. So its batteries have gone to nothing and they're frozen out.
And Perseverance too. Not Perseverance. Opportunity was in a dust storm for so long that it couldn't keep the heater going. Didn't have enough power, and so it's frozen and gone too.
Yeah.
They have heaters?
Yeah.
Wow. Why didn't I ever hear of that? They have everything else. Why not? Jeez.
Someday, each of those two rovers will be the centerpiece of a park.
Yeah.
And we'll be flying there on our expensive vacations. Look at all this incredible stuff. Well, so they've got 2 years. And do you happen to know when they're going to fire off the little 2-rotor chopper?
No.
It just depends when they find a safe spot.
Are they pretty sure it's going to fly with that thin atmosphere on Mars?
They tested
Well,
it.
they tested it.
Did they? In a very thin 1% of our atmosphere.
Yeah, in a great big vacuum chamber.
Wow.
That's the big concern is how stable it will be in the thin atmosphere, which could have high winds, but no real density to the wind. So that's hard to figure out. So there are some unknowns in it.
It had to be.
Watch the video where they're testing it too.
Yeah.
Sometimes when it lands, it has these real springy legs. It would land a little too fast and kind of bounce and fall over. So they want to make sure it doesn't do that.
Yeah.
Okay, and it's got 4 little prop legs.
3.
And very little weight on it because it's got to be able to lighten the weight and what, turn up the revolutions per second or minute or whatever for those two
weighs,
rotors?
It weighs a little over 4 pounds, and the rotors go at like 3,000 RPM.
And those 4 pounds include a camera and a transmitter.
2 cameras and Wi-Fi and a solar panel.
And a guidance, in other words.
And yeah, autonomy.
Wow. Is it gonna come back to the Percy?
No.
It won't. They're gonna just let it cast off out in the distance. And
Well, it'll kind of follow along, but yeah, eventually they're going to just leave it behind.
so it's gonna be sending back to the rover, to Perseverance, the radio waves of its camera, which then send them back up to an orbiter, which then sends them to us. How do we get the pictures from the chopper, I wonder? Anybody know?
Yeah, that's how they're going to do it.
Yep.
Really? Well, there's some incredible pictures. Look at all this. Is this all Perseverance stuff, Totten?
Yes, yes.
This is
Come
the
on, Mark.
NASA site, and those are their raw images.
Oh, that's coming down. And I got to tell you, for 1% of the atmosphere of Earth, it really opened that chute.
Oh,
Well, they
yeah.
were going something like 20 times the speed of sound on Mars when they hit the atmosphere.
I guess. And can they see what the blaster thing that held it above the crane, where it is? Did it?
The sky
Yes.
crane, yeah, you can see that.
You
In
can
fact,
see
they
it.
got an image of when it crashed. There's a big cloud that appeared on the horizon when it crashed into the ground.
Wow. So I guess they're sitting there at JPL just getting pictures around the clock, aren't they, on this thing?
Yeah.
Wow, amazing. Well, we got how many, anybody take an account of how many rovers, different countries? I know UAE is around, they're orbiting, but China's got one. They settled down, didn't they?
No, they have not landed their rover yet. They're still in orbit. They're picking a spot.
If you
Who's
look
going-
at the chart, the table at the very end of the notes I sent, there's a chart of the operational Mars orbiters, not landers, but orbiters that are currently around Mars and operating.
Including the UAE, United Arab Emirates, they're just orbiting, aren't they?
Yes.
Is
Yes,
anybody going to land on the South Pole of Mars or North Pole and try to find frozen water?
we landed near the North Pole with I forgot the name of the probe, and dug down about 1 centimeter and found solid ice.
Is
So,
that right?
Mission accomplished.
Just got a text message too from Tim Crawford saying, "Is it possible to service past rovers on Mars?" And it's like, no.
Call AAA and they'll come and charge up the battery.
Yeah.
Which rover went up to the edge of a crater and couldn't make it over the side or was in danger?
No, Opportunity actually went over the side and down into Victoria crater.
Oh, it did.
Yeah.
And those suckers are thousands of miles apart, literally, on the planet Mars, aren't they?
Yeah.
Wow. You suppose they're ever going to duplicate a landing site and have two of them side by side and see if they can land right next to an old?
Well, this rover, Perseverance, is collecting samples about the size of a piece of chalk that it puts in little sealed containers, and it's going to make caches of these containers. You saw in the earlier thing Tom showed where it kept coming back to the same place. And
Right.
that's where it's dropping off these little cylinders. And then they're going to land another rover that's going to come and pick those up. And then it's going to put them inside a little rocket and launch them up into orbit. And then there's going to be an orbiter that's going to come along and pick those up and bring them back to the Earth.
Wow.
Do they have a timeline on that? Are they building that rocket and that?
It's a lot of it's still up for grabs.
Wow, amazing stuff. And they have a drill that will actually go through some of the rock on Mars's surface?
Yeah, sure.
I don't know. That's an awful, considering it's all run by, well, maybe it's got superpower with the nuclear engines, as you said, and nuclear power on. There it is.
Yeah.
There's a very funny video. Let me see if I can call it up here. Go ahead and keep talking while I try to find this.
Well, how are you going to throw it on our screen? Tom, you're going to need it, aren't you?
No, I can do it.
Can you? All right.
Yeah.
I'll you take the moment to tell you right now, if you do not receive your Santa Barbara Astro Unit newsletter, it goes out each month from our editor, Tom Whittemore. Please just visit the club's webpage, all right, SBAU.org, and see the link to the PDF file there. Past newsletters. All
And I think
archived.
Tom has the newsletters archived all the way back to 2007.
Is that right? They're all
Yeah, last time I looked, they were there. Uh-huh.
Jerry, unless you called it up, Chuck, did you get it?
I'm still hunting.
Jerry, what's your topic going to be in the coming newsletter for April? You know?
I don't know. What would you like to see?
Well, there's a surge in things going on every day. There's a new launch. Are you aware they launched one from Canaveral northeast last night, not southeast? Because they saw a big splash of light in the sky off the coast of New Jersey.
I think that was 4 Starlink satellites.
Yeah, 4. Actually, I heard 60.
Yeah, they do them about 64 at a time.
Oh, I see. Okay.
Okay, I found it. So this is a funny video where you're talking about the drill, and this was with the original Mars exploration rover, so Spirit and Opportunity. Let's share this and fire it up.
Oh, okay.
So there's the drill.
Okay. Oh, here it comes. Okay.
Oh yeah, drill.
Yes. Spit into the sink and then we'll come in and we're going to drill.
What?
Oh my God. What the hell was that? Watching Demolition Derby.
So you had to be there.
Yeah, I got it. That's funny. I thought they've been doing this already with Curiosities and other rovers.
Yes.
They've been digging, but they're
They
analyzing
tried,
it.
one of the other ones was supposed to do push down into the soil, I think, and it didn't work so well.
No,
That was
previous one-
Insight.
Yeah, and there was a previous one that did drilling with limited success also.
aha.
Yeah, I understand that. The samples were called Mars bars.
Well, other than the fact that we're in the Milky Way bar, gentlemen, I guess we're down to the wire here.
Okay.
Tom, you want to tell us how people can watch this? See us again?
Yes, people can see us on the SB Space Astro Unit channel on YouTube, and it'll be you can see the live show replayed there. I've got how many viewers? I got 3 watching currently, which is probably 1 or 2 of them are me. So Tim Crawford's been watching. So it is possible to watch us live on Zoom every Monday morning, 11 a.m. approximately, or see the replay. Just go to the channel for the Santa Barbara Astronomical Unit, the YouTube channel that I have there, which I call just SB Space Astro Unit on there.
Oh.
So
Like they say at NASA, there's no other way to go but up for us, getting more and more listeners and waiting for the day the pandemic's over. How many of you gentlemen got your second shot? Are we all immunized? I haven't got mine. You got yours, huh, Jerry?
Yeah.
How about you, Bruce?
I'm 2 weeks past my second shot. I'm immune.
Oh, okay. And you, Whittemore?
I had just my first.
All right. Same with me. And you too, Chuck.
Just one for me.
Well, give my
Yeah, my
love to your-
second shot really wiped me out.
It did? Well, thanks a
Yeah.
lot. Can't wait to get mine now. Good Lord.
I mean, I was in sort of a brain fog all day, and then I slept for 10 hours, and the next day I was pretty good.
Okay.
That shows you it's working.
Yeah,
Yeah.
I just got a sore arm for about a day and a half.
Yeah, same here. I got a little
Oh,
sore.
yeah.
The alternative is a lot better, you know. I mean, this
But
alternative.
getting brain fog, I don't think I would have noticed having a new brain fog. But
Well, all right, you guys, we'll do it again next Monday morning, 11 a.m. If we don't have any problems and the creeks don't rise. Tom Totten, Jerry Wilson, Chuck McPartland, Tom Whittemore, and Bruce
Murdoch.
Bruce Murdoch. We'll hopefully
next time.